Hi, Jam asked. In the reaction, 3 moles of copper-2 oxide reacted with 2 moles of ammonia to produce 3 moles of copper, 3 moles of steam or water, and 1 mole of nitrogen gas. And the question said, how many electrons are transferred for each mole of copper produced? And we were given Avogadro's constant as 6.02 times 10 raised to the power 23. So this question is interested in the number of electrons transferred. Okay, looking at that equation there, if you have the knowledge of oxidation reduction, you will know that for copper we have, this is copper-2 oxide, which gained electrons to form copper. So hence, ionically, copper-2 ion gained electrons to form copper metal. So the oxidation number of copper here is +2, and the oxidation number of copper on the product is 0. There is electron gain. And looking at that, for each mole of copper formed, 2 electrons were gained. And in this equation, 3 moles of copper were formed. Hence, each mole of copper formed, we have to gain 2 electrons. So since the question is interested in each mole of copper, no need of calculating the total. The total number of moles of copper formed, we need to gain 3 times 2, which will mean gaining 6, which means gaining 6 electrons. But since the question is saying each mole of copper, so for each mole of copper formed, 2 electrons were gained. But the question said, how many electrons? As usual, once the question is demanding for number, we bring in the Avogadro's constant. Hence, 1 mole of copper involves 6.02 times 10 raised to the power 23 atoms. But the question said, how many electrons? Since this 1 mole of copper was formed by gaining 2 electrons, we multiply by 2 because this 1 mole is equivalent to that 2 electrons that is gained. Hence, we say number of electrons transferred for 1 mole of copper produced is equal to 2 times 6.02 times 10 raised to the power 23. This is just to convert it to the number of the particles required, which will give me 1.204 times 10 raised to the power 24, approximately 1.2 times 10 raised to the power 24 electrons. So this is it. So the correct answer here is C. Bye.